Is there another planet that's very close to Earth, kind of like us, where there could be a civilization? Yeah, I mean, the closest star system to us, Proxima Centauri, actually has unexpectedly, the James Webb Space Telescope discovered city lights 7 trillion kilometers from Earth. People are now questioning whether life exists on other planets in light of this incredible discovery. The closest star to Earth, Proxima Centauri B, was the focus of the telescope, which revealed that it was emitting oddly brilliant lights. Why do the lights on Proxima Centauri B appear to be city lights? Is this an indication that life exists anywhere besides Earth? Join us as we investigate how these odd objects were discovered in orbit by the James Webb Space Telescope. For many years, researchers and the general public have been hoping to get a glimpse of extrasolar life. We have welcomed any evidence that this intergalactic fantasy is real. Not long ago, the James Webb Space Telescope provided some scientists with the greatest surprise of their lives: conclusive evidence that life exists in space. The unusual lights that appeared to be coming from the globe Proxima Centauri B appeared to be lighting up a distant city. As the James Webb Space Telescope gazed into space and transmitted vital data back to Earth, the idea that an alien city may exist on Earth astounded scientists, since this existence appears to be the one they have all been waiting for. They are all perplexed. If this is accurate, then sentient life forms are operating societies in space that are extremely different from our own, and we are only now learning about them. NASA experts wondered how long the city lights had been there, waiting for someone to develop the technology to see them, as they gazed at the lights located 7 trillion miles from Earth. According to Columbia University physicist David Kipping, the Proxima B exoplanet city lights make it difficult to comprehend. It is known that most rocky planets absorb sunlight and emit infrared radiation, he said, because the heating patterns in this star system differ from those on other worlds. Not for this world, but yes, compared to its star Proxima Centauri, it has a radically distinct infrared nature. This was a good study for the James Webb Space Telescope, which was the perfect instrument for the job. The James Webb can detect infrared wavelengths with ease, because it has the most advanced infrared imaging technology. We will be able to learn a great deal about the atmosphere of other planets from the distinctive heat signature of Proxima B. By using the telescope, scientists aim to learn more about the secrets of this planet's atmosphere. Additionally, they are interested in learning whether life is feasible on this extrasolar planet. The James Webb Space Telescope is prepared to investigate nighttime activity at Proxima Centauri B thanks to its infrared sensitivity. The James Webb can observe even the smallest rays of light from space, something that most space cameras struggle to detect in the immensity of space. It's the ideal method to determine whether the reports of city lights on Proxima B's night side are accurate. As long as they fall within a frequency band 1,000 times smaller than sunlight, the telescope can detect any artificial light in the universe. It's fascinating to see how the surface of Proxima B blends with its stellar features. The star's beaming energy is captured by numerous solar screens on the exoplanet's day side. Light is also reflected back into space by its spectrum edge. Like us on Earth, Proxima B experiences day and night cycles after completing its orbit around its host star, Proxima Centauri, with the sun heating things during the day and cooling them at night. It is well known that the composition of the planet affects its temperature. In this instance, if Proxima B lacked an atmosphere, there would be a significant difference between day and night. The day side would be as hot as a black body, and the night side would be pitch black and frigid if not for the seas and gases in the atmosphere. The degree of temperature change is of great importance to astronomers who want to understand more about the atmosphere of Proxima B. Because of its unparalleled infrared imaging capabilities, the James Webb Space Telescope can rapidly examine the planet's heat emissions, providing us with valuable information on its atmosphere. Interestingly, the orbital period of Proxima B coincides with the orbit of the James Webb Telescope around the Earth. This indicates that 11.2 Earth days are needed to completely see its day and night phases. The next step is to examine the chemistry of Proxima B's atmosphere to see whether it is capable of supporting life, given that it most likely has one. Important indicators that a location is habitable include gases like oxygen, water vapor, and methane. The presence of these components may indicate that the planet has living circumstances. However, in order to determine this, scientists must pay particular attention as they capture and examine light rays as they track through the planet's atmosphere. Although the James Webb is excellent at characterizing planet atmospheres, it struggles to detect bonded oxygen, a crucial indicator of life. The camera can still search for other elements in the atmosphere, such as ozone, which also exhibits evidence of life. Despite these issues, the fact that the James Webb Space Telescope can only view a small number of the nearest habitable worlds to Earth is another crucial consideration. In order to conduct a more thorough investigation of the atmosphere, astronomers are anticipating the arrival of ground-based telescopes such as the Extremely Large Telescope, ELT, which is scheduled to begin operations in 2028, will enable us to take a closer look at the atmospheres of distant exoplanets. The ELT will be able to collect data that will help us determine how livable those worlds might be. However, in the meanwhile, the James Webb Space Telescope remains a valuable instrument for our investigation of the unusual phenomena that occur on distant exoplanets. Despite its shortcomings, the Webb telescope has the potential to transform our current and future perspectives on planet exploration. Reducing the intense light from a planet's star host is the primary objective of future space telescopes. Scientists will be able to observe the planet's feeble light reflections more clearly thanks to this. They intend to accomplish this by using large external satellites or inside masks that resemble shields, similar to how you cover your eyes from the sun to improve your vision. Because host stars will emit less bright light, future telescopes will be better equipped to examine dim light reflections from distant exoplanets. This will make it possible to investigate their atmospheres and capacity to sustain life in more detail. Nevertheless, there are certain issues with this approach, such as the requirement to distinguish between gases produced by natural phenomena, such as volcanoes, and gases produced by living organisms. The desire to discover more about exoplanets and distinguish between genuine and fake evidence of life remains strong among astronomers. We get a preview of the incredible discoveries that science will make in the future thanks to the work done on exoplanets by the Webb telescope. We discover more about the world and our place in it as we continue our space adventure. Despite decades of searching space, scientists have yet to discover conclusive evidence of extraterrestrial life, but the hunt for additional forms of life continues. For a very long time, people have been wondering if they are the only ones on the planet. The James Webb Space Telescope is now being used by scientists to search for evidence of extraterrestrial life in secret organizations. People have been asking this question for a very long time. According to a popular legend, aliens are out there in the stars waiting to be discovered. American scientists Jill Tarter and Thomas Pearson established the Search for Extraterrestrial Intelligence (SETI) Institute in 1984 to investigate this theory. The goal of the non-profit organization is to look for radio signals from space throughout the cosmos. The ability of radio waves to travel great distances without being lost or ingested, unlike many other forms of radiation, makes them intriguing. Despite searching for more than 30 years, SETI has not yet discovered any such indications. However, Jill Tarter remains optimistic and believes that new technologies will assist in expediting the hunt. She believes that if everyone in the world is permitted to participate in the hunt for extraterrestrial companions in space, fresh discoveries will be made. Additionally, NASA has stated that city lights from a planet near Earth might have been visible to the James Webb Space Telescope. The James Webb is designed to uncover hard-to-find information about galaxies, planets, stars, and the early formation of space. It is the best approach for people to learn about the universe. By separating specific light wavelengths with its ST camera and filters, the telescope enables researchers to examine the physical and chemical composition of distant celestial objects. The James Webb Space Telescope is constantly searching the atmospheres of other worlds for minute indications of life. This aids us in solving some of the most intriguing riddles in the cosmos. The discovery that there is more mass in the world than previously believed is one of these mysteries. This mass raises additional questions regarding the size and form of the early cosmos because it is concealed in very big galaxies. People have little knowledge about the universe outside of our solar system. 20 years ago, more than 4,000 exoplanets had been discovered by astronomers to orbit distant stars. This demonstrates the extent to which technology and our interests may lead us in terms of space. NASA believes that these findings are just the beginning. Scientists estimate that there are trillions of undiscovered exoplanets in the universe. Although space exploration has been going on for decades, scientists continue to look for extraterrestrial dwellings in areas that humans have never visited. There have been moments along the journey when hope appeared. It was confirmed that plants may grow on other planets when the Galileo spacecraft visited Jupiter, and its spectroscopic instrument revealed a distinct range of wavelengths. For the first time, scientists discovered a biosignature indicating that life exists throughout the cosmos. This biomarker was called vegetation red edge, VRE. In order to discover extraterrestrial life, the VRE thoroughly examines the way light reflects off objects. By precisely measuring the orbital parameters of potentially habitable planets that fall in the habitable zones of their alien parent stars, the VRE will assist the James Webb Space Telescope in its quest to unravel the mysteries of extraterrestrial environments. Once these are located, the VRE can provide us with crucial hints for searching for extraterrestrial intelligent life, beginning a new quest to uncover the mysteries of the cosmos. The atoms and molecules in the atmosphere absorb the fragmented light, which has various wavelengths as sunlight passes through the layers. Using spectroscopic analysis, one can determine the meaning of a distinctive spectral pattern, such as a fingerprint. People typically assume that the James Webb will be able to detect light from stars when it enters a planet's atmosphere. As the absorption process progresses, the James Webb may be the final element needed to determine the composition of the atmospheres of these worlds. Based on our current understanding, the atmospheres of planets roughly the size of Earth include large amounts of carbon dioxide, nitrogen, and oxygen. Although life could exist on these types of planets, the absence of odd compounds may indicate the presence of other life forms in advanced societies. Scientists may be able to establish beyond a reasonable doubt the existence of advanced societies outside of our solar system with the use of man-made compounds called chlorofluorocarbons, CFCs, which are used for cooling and other industrial applications. It will be evident that life exists outside of our solar system if the James Webb detects these artificial substances in the atmospheres of exoplanets. This opens up new opportunities for astronomers to investigate the composition of the atmospheres of other worlds and the remote possibility that civilizations exist outside the Milky Way. There are possibilities for extraterrestrial life that are not compatible with earthly biology. Although temperate regions are typically thought of as having abundant life, the reality may be far more harsh and nuanced. For instance, the intriguing group of organisms known as extremophiles, which are primarily composed of bacteria, challenge our preconceived notions about the environments in which life can flourish. These resilient creatures may readily survive and thrive in environments that humans would consider quite harsh. Extremophiles can live and flourish in environments with a pH of less than 3 and in temperatures as high as 250 degrees. An excellent illustration of how long life can last is their capacity to endure the most trying circumstances. As a result, the vast expanse and diversity of the universe demonstrate the need for a highly broad search for extraterrestrial life. Studying planets that are like Earth and orbit stable stars like the Sun is a terrific idea. Additionally, considering other exploration avenues, such as exoplanets close to red dwarf stars, which are prevalent in the universe, opens up new research avenues. Although red dwarfs are typically cooler and less brilliant than our Sun, they allow us to investigate the possibility of life in a variety of environments. Due to their long lifespans, red dwarf stars have plenty of opportunity to undergo sluggish, intricate evolutionary processes. An important new discovery made by the James Webb Space Telescope is the discovery of a new planetary system known as TRAPPIST-1. It's fascinating that the planets in this system resemble Earth and may be capable of supporting life. Earth-like planets in the TRAPPIST-1 system, a faint red dwarf star, and 7 Earth-like rocky planets orbit around make up the planetary system known as TRAPPIST-1. 3 of these 7 planets have been determined to be habitable, indicating that their surfaces probably contain liquid water. Despite being larger and warmer than the TRAPPIST-1 star, Earth's sun emits a gentle light that is comparable to what we experience on Earth. Researchers have meticulously examined the star's light in hopes of identifying the conditions necessary to make the planet TRAPPIST-1 habitable. The red dwarf star is located 41 light-years away in the sign of Leo. According to the James Webb's analysis of the entire planet system, the discovery delighted Ward Howard, a NASA senior fellow and main author of the study at the University of Colorado Boulder. The James Webb allowed us to search for planets around other stars with atmospheres similar to ours for the first time in history, he said. Additionally, he discussed the significance of studying exoplanet stars in order to understand their solar systems. The fact that Proxima Centauri is only 4.25 light-years from the Sun makes it stand out among the many stars in the universe. Despite being the closest star to Earth, it is barely visible at night due to its weak luminosity. The star isn't extremely bright, so any planets that may support life around it would need to be 20 times closer to Proxima Centauri than Earth is to the Sun. On August 24, 2016, astronomers discovered a planet in the habitable zone of Proxima Centauri that was 1.3 times as massive as Earth. This discovery was an exciting discovery. The ideal amount of light in this Goldilocks zone allows ice to melt into water and maybe support life. The fact that Proxima b is an exoplanet orbiting its parent star Proxima Centauri is peculiar. Despite being just 4.6 million miles away from its red dwarf star, Proxima b is in an environment that is hostile to life. Strong solar winds could harm its atmosphere because of its close proximity to the Sun. Despite these issues, Proxima b receives enough sunlight to maintain an Earth-like temperature, which suggests that liquid water could exist there. Additionally, tidal locking, where one side of the planet is always in direct sunlight and the other is always in darkness, has been observed by scientists. The connection between the Earth and the Moon is comparable to this. Contrary to what most people would anticipate from a star of that size, Proxima Centauri emits a feeble brightness. Despite its issues, Proxima b has several intriguing opportunities. Liquid water may form on its surface if it has an atmosphere that retains heat, which would set off a series of events that would allow humans to live there. Animals that live on land or in the air could evolve from life that began in the ocean. However, Proxima b receives only 65% of Earth's sun radiation, making it improbable that life could exist there. Additionally, the planet's tidal locking causes significant temperature fluctuations, ranging from extremely hot during the day to extremely frigid at night. These extreme conditions are exacerbated by the proximity to Proxima Centauri, where strong radiation, including ultraviolet and X-rays, might eventually destroy living beings. High-energy particles are also hurled at Earth by solar flares. If Proxima B's magnetic field is weaker than Earth's, it may lose its atmosphere, and life would not be able to survive as a result. According to realistic models, planets trapped in a tidal loop such as Proxima B are likely to experience rapid atmospheric collapse, leaving volatile gases outside to freeze at night. Whereas volcanoes replenish the atmosphere on Earth, Proxima B lacks comparable mechanisms. Beyond what is visible from the surface, this extrasolar planet has secrets that raise the possibility of highly developed extraterrestrial civilizations. Given the extreme conditions on Proxima B, it is feasible that extraterrestrial life forms, possibly belonging to the extremophiles group, are sheltering there. Although nothing is known about the strength of the magnetic field or the volcano on Proxima B, the possibility of life in the planet's atmosphere is still remote. Proxima B's city lights significantly increase the likelihood of life there, and support our continued quest for evidence of highly developed extraterrestrial civilizations. The search for extraterrestrial life has gained popularity in recent years. This is due to the belief that more developed alien societies would have developed superior technology to withstand the hostile atmosphere of Proxima B. According to some researchers, these extraterrestrials might have installed massive solar panels on the planet's day side in order to harvest energy from the star and use it to warm and illuminate the planet's dark side. The discovery of Proxima Centauri B has sparked a fierce competition among scientists to determine whether the planet crosses the face of its star in the same way that Earth does. By measuring the planet's movement, scientists would be able to determine its size, mass, and density, in addition to providing them with important information about the elements on its surface. This would demonstrate that it is composed of rocks. Even if research on Proxima B is challenging, understanding this extrasolar planet is nevertheless crucial. As long as people are curious about what exists outside of our solar system, they will continue to search for extraterrestrial life. Another issue with Proxima Centauri is that it flares up frequently, making it more difficult to study a habitable world like Proxima B. Fortunately, the James Webb Space Telescope avoids these flares and captures crucial images and data about the universe that will be analyzed on Earth. How do you feel about the artificial city lights that were seen 7 trillion miles away from Earth on Proxima Centauri B? Please share your thoughts in the comments section. For more intriguing videos, remember to follow, like, and share.